In the name of God. Hello, dear students. My name is Masood. I'm a physics teacher. We are at your service to explain the physics curriculum, grade 10. So far, we finished chapter 1, and we solved some questions about the, let's say, sections within this chapter. We solved some questions from chapter review, and we finished question 20. Right now, I wanna, let's say, solve the question 21 right now. Let's get started. Question 21, a fisherman catches two sturgeons, two fishes. The smaller of the two has a measured length of this number, 93.46 centimeter, 2 decimal places and 4 significant figures. It mentions actually it describes the number. This is the question actually, and the larger fish has a measured length of 135.3 centimeter, 1 decimal place. After decimal place, we have only one figure, and 4 significant figures, 4 sig figs actually, because they are all non-zero digits, so they considered, let's say, significant figures. What's the total length of the two fish? Right, total length. We have to, let's say, sum, or we have to add them up together. So take the summation of these numbers, 93.46 plus 135.3 is equal to 228.76 centimeter. So right now, I told you about the, let's say, the rules that I explained it for you, especially about the sig figs and operations, let's say, related to the sig fig. Here we have addition, right? In addition, we focus on what? We focus on the number with the least, let's say, decimal places. Which one has the least decimal place? This one, right? So we focus on this one. The answer should contain 1 decimal place, right? So whenever you, let's say, add them up together, you get this number. So we have 2 decimal places. That's why we have to, let's say, convert it to 1. We have to reduce it to 1 decimal places. So what shall we do, right? The last digit is 6. That's why it's round up. You have to drop this number, right? We have to drop it, and after that, and we have drop up actually, because we have more than 4. You drop this one, and you add 1 unit to the 7, and the answer will be what? 228.8 centimeter. This is the answer. That's actually, it's about the question 21. Let's move on to question 22. Question 22, a farmer measures the distance around the rectangular field. There's the rectangular field. The length of each long side of the rectangle is found to be 38.44 meters, and the length of each short side. So this number actually, this number is dedicated for what? For the longer side, 38.44, this number, and 19.5, this is the length of the shorter one, the shorter side. So what's unknown? It says, what's the total distance around the field? So we look for total distance around the field. Around the field, so we have to, let's say, find what? We have to find circumference of the rectangle. So what's the circumference? If you don't, let's say, don't know what the circumference rule is, just add them up together. Add the 4 sides together, and this is the circumference. Or you can say, you can write, let's say, 2 multiplied by, let's say, L plus W, means length plus width. We can write this. Let's say, find the circumference. This is the circumference actually. right? 115.88 meters, right? So all here we have what? We have an operation actually. What's the operation here? Let's say we have a excuse me, we have addition. That's why you have to focus on what? We have to focus on the figure with the least decimal places, right? Which one has the least decimal place? This one. That's why the answer should contain only one decimal place, one figure, let's say after the decimal point. That's why you drop this one, because we have round up the number, the last digit is more than 4 actually. You drop it and you add the number 1 to the penultimate digit. It will be 15.9 meters. That's it, right? Let's move on to another question. Question 23. Uh, question 23. Suppose that two quantities A and B have different dimensions. So we have two, let's say, two different quantities, because it says they have different dimensions. That's why they are, let's say, different from one another. They are not the same. Which of the following, let's say, arithmetic operations could be physically meaningful? Which one is, let's say, meaningful? Which one is meaningless? So A and B are what? A and B are two, let's say, different. They are two different physical quantities. Let's say, for example, A is force. For example, A is force, and B is what? B maybe is velocity. Let's say it's velocity, right? Force and velocity. Or let me change it to force and, for example, acceleration. Force and acceleration, right? This is acceleration. Acceleration. Let's move on to the first one, A capital plus B capital. Why do we say it's meaningless? Because whenever you add force and acceleration, actually this is, let's say, meaningless in physics. It's pointless. It doesn't have any meaning. For example, 20 Newton plus 2 meters per second. It can't be. It's not accepted in physics. That's why we neglect it and we say meaningless. So what's the note here? The most important thing, and I want you to keep it in your mind, that about the two different physical quantities, you are not allowed to add them up together. For example, you cannot add force and acceleration or force and velocity. You cannot, let's say, add two different quantities together. You can give other examples by your own brain, actually. Maybe you say, I say time and, for example, time and distance. You cannot add time and distance. That's why it's meaningless. Let's go to the B. B, A divided by B. A divided by. Why do we say it's meaningful, actually? Let me examine it for you. Let me examine this one. B, I'm gonna, let's say, solve B for you by other color. A over B. If I say A over B, F, for example, let me write it here. F divided by acceleration. What's this? Actually, is it accepted in physics or not? Actually, it's accepted. It's meaningful because F over M means what? Means mass. What's this? This is Newton's second law. You can give another example. That's why it's meaningful. So you can divide. We can divide different quantities by one another. It works actually. So it's meaningful. Let's move on to another one. C. Let me write the answer of the first one here in front of the let's say, question. A plus B. I say F force plus acceleration. That's why it can't be. But this one, let's say, works. Let's move to C actually, A multiplied by B. Why do we say it's meaningful? For example, whenever you multiply force and acceleration, it works actually. It has, let's say, it's meaningful actually. We cannot say it doesn't work. It works. That's why we accept this one. We have a lot of other examples. Let me think about, for example, m multiplied by v. Think about this one. Mass multiplied by velocity. Mass multiplied by velocity becomes momentum. It's a very famous rule especially in grade 11. This rule, you encounter this rule. And think about the equation of Einstein, conversion, let's say energy conversion, mc square, right? You see? So mass multiplied by velocity, actually c is the speed of light. That's why multiplying two different quantities are, let's say, is meaningful. It has no problem. Let's move on to the last one. It says a minus b. Actually, let's say the rule for addition is as the rule for, let's say, subtraction, and the rule for multiplication is as the rule for, let's say, division. That's why a and d are similar. F plus b, f plus a, first, let's say, plus acceleration. We said that it can't be. We cannot accept it. It's meaningless actually. Here, the same thing we say here. We cannot, let's say, subtract acceleration from force because they are completely different. You cannot subtract acceleration from force. That's why it's meaningless, right? So keep in mind that multiplication and division work actually for two different physical quantities, but addition and subtraction don't work for two, let's say, different physical quantities. Right? Let's move on to question 24. Estimate the order of magnitude, power of 10 actually, of the length in meters of each of the following, let's say, each of the following. We have some, let's say, some objects or things. We want to, let's say, estimate the order of magnitude for each. For example, a ladybug. A ladybug. Let me tell you something about for example, insects in general. Whenever you hear the name of any insect, and the question wants you to, let's say, estimate the order of magnitude of the length of this insect, think about for example, 10 to the power negative 2. So the length of the insect is written in 10 to the power negative 2, means centimeters, right? 10 to the power negative 2 means centi. So that's why this one means centimeter, right? So a ladybug, 10 to the power negative 2 meters. If I change the question, for example, from ladybug, I say housefly, you have to say 10 to the power negative 2 centimeter. I don't know, cockroach, 10 to the power negative 2. Any other, let's say, a locust, for example, any other insects, you have to write 10 to the power negative 2 meters, right? So it's measured in centimeter. Let's move on to B, your leg. Our leg, actually, human leg, is measured in 10 to the power what? 10 to the power 0 means 1. Maybe the leg of a person is 1 meter, or if the person is very tall, it reaches, for example, 1.5 meters, especially about the basketball players, actually. So 10 to the power 10 to the power 0 meters means 1 meter. And it's, let's say, reasonable. The leg of any person is approximately 1 meter. See your school building, right? It's the length of the school building, actually. It's measured in 10 to the power 1, right? Or 10 to the power 2. Either you say 10 to the power 1 meters or 10 to the power 2 meters. It can be. If the school is very, let's say, large, you can write 10 to the power 2 meters. Both options are right. Right? D. A giraffe. A giraffe, why do we use 10 to the power 10 to the power 1 meters? I think I explained it for you. A mature giraffe has a height of 6 meters, mature giraffe. That's why 6 is very close to 10 to the power 1 than 10 to the power 0. That's why 10 to the power 1 is the order of magnitude of the length of a giraffe. Let's move on to the E, a city block. A city block is like an actual neighborhood. Think about a lot of houses. They are surrounded by trees, right? So that's why a group of houses together is measured in what? Is measured in 10 to the power 2 meters, not, for example, 10 to the power 1 or every other, let's say, order of magnitudes, right? Think about your, for example, your alley in your neighborhood. Maybe you, let's say, start from at the edge of the, let's say, alley to the edge, to the end of the alley. Whenever you measure it, maybe it reaches 100 meters or sometimes more than 100 meters. That's why the, let's say, order of magnitude of city block is 10 to the power 2 meters. Let's move on to another question, question 25. If an equation is dimensionally correct, good question. If an equation is dimensionally correct, right, does this mean that the equation is true or not? We have an equation, dimensional is correct. Let me give you an example. For example, I write an equation for you here. I want to, let's say, write an equation here for you. For example, I say nuclear energy, or I can say, for example, yeah, nuclear energy, nuclear energy actually, right, is equal to, for example, kinetic energy, right? Is it right or not? Actually, is this equation valid or not? Dimensionally, maybe it's right, because both are energy, both are forms of energy. I can say this is measured in joule, right? Nuclear energy or any type of energy is measured in joule. And kinetic energy is a type of mechanical energy and it's measured in joule as well. So dimensionally is work. Dimensionally it works, excuse me. I can say dimensionally has no problem. But actually physically it's not right, right? It's not valid. You cannot compare kinetic energy, for example, in classical mechanics with nuclear energy in relativity theory. They are completely different. That's why, let's say, dimensionally it's right, but let's say I can say physically it doesn't work. So let me read the answer for you. It says no, it's not accepted. Dimensional consistency indicates that the equation may be valid. The equation may be valid actually, but it's not necessarily valid. Question 26. The radius of a circle inscribed is written in any triangle in a triangle whose sides are A, B, and C. So I have a triangle A, B, and C. Actually, this is the dimension of the triangle given by the following equation. We have an equation for finding radius of a, let's say, of a triangle, which S is an abbreviation for A plus B plus C. So S is equivalent to what? S is equivalent to A plus B plus C divided by 2. Right? Check this formula for dimensional consistency. We want to, let's say, check this question. Actually, S and A and other, for example, ABC and S All of these, let's say, variables are what? They are all about the, let's say, about the length, about the sides of a triangle. That's what they are all measured in meters. Whenever you subtract one, let's say, from the other, they'll, let's say, the unit, let's say, remains meters, right? The unit does not change. For example, 5 minus 2 becomes 3 centimeters. 5 minus, for example, 1, 4 centimeters. So I can say we have meters here, and meter here, right? Divided by s, and s by itself, actually, s is measured in meters as well. That's why I want you to, let's say, multiply these dimensions together. M multiplied by m becomes m cubed divided by m. So it will be, and by the way, r is the radius of a circle, right? R is the radius of a circle. So r is measured in meters. Here inside the, let's say, square root, we have meter times meter becomes cubic meter divided by meters, right? So I can cancel this meter with 1. It becomes meter square. Under the square root, whenever you take the square root of this, let's say, of the right side, m will be equal to m. So what's this? What does it mean? It means the equation is valid. The equation, let's say, consistency, I can say dimensional consistency is achieved. It's right. So I solved it for you here. Let me, question 25. The period of a simple pendulum defined as the time necessary for one complete oscillation is measured in time units and is given by the equation. You have this equation. So time, t means time period. 2 pi is a fixed number, radical. L means length of a pendulum, and ag means acceleration due to gravity, actually. Right? It gives actually it gives us these informations, this information, which has units of length divided by time is squared. Check this equation for dimensional consistency. Let's check. Let's say check it together, whether the equation is right or wrong. Let me let's just solve it for you right now. We bring the equation down, right? You have to write down the equation. T is equal to 2 pi radical L over H. T means time, right? Time period. That's what time is measured in second. 2 pi, neglect 2 pi because fixed numbers have, let's say, have no dimensions. They have no units. Ignore it. Focus on this, let's say, radical. Radical L over Ag. L means length of a pendulum. You know what pendulum is. This is a pendulum, actually. This is a pendulum. The pendulum vibrates back and forth. This is called pendulum. And L means the length of a pendulum, means from here till here. This is the L, right? Ag, I told you, Ag means acceleration due to gravity. So L is measured in meters, right? Ag is measured in meter per second square. Actually, it gave these information to us. Actually, question gave this information to us because it says acceleration due to gravity, which has units of length divided by time square. Length, what's the unit of length? Meter divided by time square means time square actually means s square, right? S square. That's why it says the unit of acceleration is the unit of length divided by the unit of time square. What does it mean? Meter per second square, like this, right? So right now, the left part becomes S. Let's move on to the right part. Every day, let's say, excuse me, uh, every time when I want to, let's say, solve the problem, I repeat this technique actually. Whenever you have, for example, two fractions divided by one another, the far, let's say, part with far part, multiply these, let's say, variables, and they go to the numerator, and the near with near. So under the square root, we have what? We have meter, look here. Right? Let me write it here. Radical meter second square divided by what? Divided by meter. So can I say meter cancels meter? Yes. So under the square root, only we have a second square. That's why a radical with power will go actually, and S becomes S. S is equal to S. What does it mean? Means dimensions are consistent. The equation is valid, right? It has no problem. Let's move on to other question. Question number 28. Question number 20. In a desperate attempt to come up with an equation to solve a problem during an examination, student tries the following, right? The student tries the following: velocity in meter per second, the whole bracket square is equal to acceleration in meter per second square multiplied by time in second. So we have an equation. Let's say simplify it for you. Instead of, let's say, velocity, I use abbreviation for velocity. I have to write v square, right? Use abbreviation for each word. For each quantity, we have to use abbreviation. What's the abbreviation of acceleration? Acceleration. The abbreviation of acceleration is a, yeah? Does it have any, let's say, square? No. So just write the a here. And time actually has no, let's say, power, has no exponent. That's why the v squared is equal to a times t, like this one. Velocity is measured in meter per second, right? Let me, this one, velocity is measured in meter per second. But why do we square it? Because in the, let's say, original equation, we have a square. In the left part, we have a square. That's why we have to square meter per second. It will be meter per second square, and after that, the, let's say, next step will be meter square divided by second square. So what do you say about the right part? About the right part, acceleration is measured in meter per second square. It gave it us to, in the equation. This is the unit of acceleration, meter per second square, multiplied by t. Unit of time is second, right? So all of these information are available to solve the equation and check the validity of the equation. The left part becomes meter per second square, right? But here, I want you to put a denominator of 1 to the s and multiply numerator with numerator, denominator with denominator. So what do you get here? What do you get? Let's say second, simplify with one exponent, and the last answer of the right part becomes m over s. So is this equation valid? Is the left part, let's say, balanced right part or not? No, they are completely different. Meter square divided by second square is not equal to meter per second. So this equation is wrong. We don't accept it, and actually this is the solution of equation. And at last we can say the equation is not valid. Dimensional consistency is not achieved actually. Guys, that's all for today.